Leia, Han Solo, and whatever this large furball is.
Chewbacca.
I'm sure you've come searching to destroy the Death Star, but that's impossible unless you somehow understand discontinuity. To access the destroy button, you must first solve 3 problems, each regarding continuity.
I smuggle, metal brain. I don't do math.
I would wish you well, but the Force is not with you.
I've got a bad feeling about this.
I have an idea.
Yeah, that's great, Your Highness. Kill us. That'll work.
No, you idiot. I know how to solve these.
Use the 3 rules, Leia.
This question asks if the piecewise function g of x is continuous at x equals 6. We can find that out by using the 3 steps. First, we plug in x equals 6 to g of x. When we plug it in, the answer is 5. The limit as x approaches 6 doesn't exist because from the left side it approaches 12 and from the right side it approaches 5. Therefore, it doesn't exist. And then the third step is to see if they're both equal to each other, the g of a value and the limit as x approaches a. They aren't because g of 6 is 5 and the limit doesn't exist and those aren't equal. Therefore, the function is not continuous at x equals 6.
Wow, you actually are smart.
By looking at this graph and using the 3 rules we just learned about, we can figure out what the points of discontinuity are. At x equals -4, the f of -4 value or y value at x equals -4 is 3, but the limit doesn't exist. Therefore, there's a point of discontinuity and the graph is not continuous at x equals -4.
Is there a point at -4, -2?
There is an open circle, which means that while x approaches -4 from the right, the y value approaches -2. But the value is at -4, 3 where the closed circle is.
At x equals -1, the f of -1 value or the y value is 4 and the limit is 4 as well. That means it is continuous at the point -1. When x equals 2, the y value or f of 2 value is -1, but the limit again doesn't exist. Therefore, there is a point of discontinuity and the graph is not continuous at x equals 2. At x equals 4, the y value doesn't exist because there's an open circle. And when there's an open circle, that means the limit approaches that point, but it never actually hits that point. There could be a hole or an asymptote, something like that. Therefore, when x equals 4, the graph is not continuous because there's no point, even though there is a limit. This is how we can use the 3 rules to determine whether the graph is continuous or discontinuous at certain x values.
Nice job, Your Royalty. We have one problem left.
We are given a rational function with a constant in the numerator and a polynomial in the denominator. So first we can factor the denominator to be the quantity of x minus 1 times the quantity of x minus 2. And we want to find where the denominator is equal to 0, because that is where the function is not continuous, because anything divided by 0 is undefined, so there would not be an f of x value when x equals these numbers. And when we set the denominator equal to 0, we get that x equals 2 and x equals 1. And those are the values where the denominator is 0. And therefore, the function is not continuous at the x values where x equals 1 and where x equals 2, because again, anything divided by 0 is undefined. That it goes for any number or polynomial or pretty much anything. So again, by setting the denominator equal to 0, we found where the function is not continuous and is undefined.
We did it!
Good thing I took AP Calculus A, B.